Good morning. The topic of today in this module 2 is identifying various fingerprint patterns. Identifying various fingerprint patterns. All fingerprints may be resolved into three groups, and each one can still be further classified. The first group is known as arch, and the second one is known as loop. Then you have whorl. In arch is characterized by lines moving from one side and going out of the other side, moving from the ridges moving in from one side and going out of the other side of the finger. If you look at the screen, the two prints that you have on the screen, the first one and the second one, the lines are going inside on one side and they are going out from the other side of the print. But so both of them are loop. That is characteristic of any loop. That is, the lines are going out from one side and going out of the other side of the fingerprint of the finger. Now, the difference between the two is that by the time you look at the lines, the innermost ridges, look at the first line, the first diagram. If you look at it, you can see where my arrow, that red arrow is. Look at the line there. Look at the line before it. You can see they bent upward a bit, just a bit. They bent upward a bit. Whereas in the second one, that is diagram 2, this figure 2, you can see that the innermost ridges, they thrust upward. They are almost vertical. So they are like as if you have a tent. And that now those two differences is where we derive their name. Their names. The first one is known as plain arch because almost all the lines are as if they are on a plain surface. There's just a little bend, but here you have up thrust. So this is tented arch. This figure 2, figure 2 is tented arch, whereas the figure 1 is plain arch. So the difference between the plain arch and the tented arch is that in plain arch you have a little bend of the lines at the middle, whereas you have an upthrust of the lines or the ridges at the middle. So that is the difference between the two subdivision of this group or of this family known as arch. So arch is the first one with two subdivisions. Then you have another one called loop with also two subdivisions. Now, if you look at this, the first figure, that's figure 4, you can see that the ridges are going from one side of the finger and going out of the same. Look at the innermost, just concentrate on the innermost lines. They move in from one side and they go out of the same side. That is characteristic of a loop. They have the curves that are going in and coming in, going out of the same side. So that is recurve from the word loop from their name means that they loop, the lines loop on one another. They loop on themselves. They loop on themselves until look at it. Apart from that one, every loop you have what we call data and core. Whereas in the previous family, you will not have anything of such. Then we are still coming to issue of core, data, and all the rest. Now look at this one. The same thing here. You have the loop. You have the ridges going in from one side and coming out of the same side. Just concentrate on the innermost recurves. You can see from one side going out of the same side. So, but the difference between these two subdivisions is that the head of one is pointing towards the left. We call it radial loop, while the second one is pointing toward the right. We call it a ulnar loop. We have radial loop, ulnar loop. In the family of loop, we have radial loop and ulnar loop. That is the two subdivision that we have. Then the third group is known as whorl. In this whorl, we have about 4 of them. We have 4 of them. The first one is known as plain whorl. The second one is known as central pocketed loop. Then we have double loop and accidental loop. Now you may be hearing loop, loop, loop. Those loops, they didn't belong to the second group that you call loop, but they belong to this whorl, and you know the reason will be clear to you later in the course of this study. So in the whorl group, we have 4 subdivisions. We have a plain whorl, central pocketed loop, double loop, and accidental loop. So these 4 are the subdivisions that you have here. Now let's move further. During examination, there are some things or some areas that we need to concentrate on, whether we want to make identification or we want to match in order to differentiate. Now, the area that we have interest in is basically the area we call pattern area. The pattern area is that part of a loop or whorl in which appear the cores, the datas, and ridges with which we are concerned in classifying. What are we saying is that when we want to classify fingerprint, there are parts of it that we need to concentrate our attention, that we need to be concerned with before we do the classification. And that is cores, the datas, and the ridges between them. The cores and the datas and the ridges between them. So we are going to define what data is and what loop is, and some other and the ridges between them, and the relevance of it. Now let's go to the data. Or before that one, what is that pattern area? How can we know the pattern area? Before that one, I will show you what we know as type line. The type line covers the pattern area. The type line covers the type area. Now look at the screen. This is a loop. Now, before we can say this is the pattern area, what you need to do is to identify the type lines. And the type lines is defined as the two innermost ridges. Look at ridge A and B. Look at it, A and B. The two innermost ridges which start parallel, diverge, and surround or tend to surround the pattern area. Look at it. Line A and B. They run parallel to one another, to each other, and on getting to this place, they diverge. And they tend to cover this place. At times, it may not be a continuous line like this, it may be a broken line. So, type line will always run parallel to each other. They are always the two innermost core. The two innermost ridges that run parallel to each other and diverge and tend to cover the pattern area. So that is the definition. So the focal point, our focal point should be the data, the core, and the ridges between them. We'll get to that one later. Now, what is data? The data, just as our usual data, our normal data. A data is a place at the mouth of the river, where the river is about to empty its content to a lake or to an ocean. At that point, at that mouth of that river, there is always, because the river normally carry sand from the upper part or the upper region to that area, and because of the fact that at that area, the speed of the river is always very slow compared to the upper part. So it will deposit its sand at the mouth of the river. At the mouth of the river where it is about to enter into the ocean or the lake. So the sand are being deposited there, and you get to a stage where the sand will grow up, will reach a level that can become a land. So that it's like an obstruction to other river that is coming. That is why you have the water at this side and at the other side. But the obstruction, the land that it has formed, is standing at the middle, very close to the area of divergence of the banks. Now, let's apply the same thing to our print. Here you have, let's use the other one. Here you have two innermost ridges. It's like a river that is bringing in water or getting to this place. Because of the fact that it's depositing sand, then you have a land. That land becomes an obstruction to water that is coming from up, and you have space here, you have space here. But this is now our data. So now the data may be a bifurcation. A bifurcation is when ridge divided into two, that is forked into two. Then it may also be an approach ridge, maybe a short ridge, or it may be a dot, just a round dot. It may be a meeting of two ridges. But what we are concerned is that place must be at the center of these two divergence, the center of the divergence, and is immediately before the divergence. So you may have 2-3 obstructions here, like maybe you have two bifurcation there. You have dot and some other ones. But the first one that is closest to the divergence point will be taken as the data. So that is our data. Then the next thing is the core. We said our focal point should be the data, the core, and also the ridges between them. Now, our we have identified our data. Then how about the core? The core is the approximate center of the impression, of the finger impression. The approximate center of the finger impression. And I want you to notice the following: that the core is placed on the innermost recurve. Now, if all these are recurve lines, but the innermost recurve, this is the innermost recurve. But in a case where we have a line that protrude from the beginning and move straight to the shoulder of the innermost curve, the shoulder is that point immediately before the head. So these are the shoulder for this innermost curve. Now, if this line grow up to that level, that shoulder, then we call it the core. That will be choosing as our core. We place our core on it. But in a case where you don't have that line and our innermost recurve is there for us to be used. So the innermost recurve is this one. So what you do is that you place your core on the shoulder of the side that is far away, that is further away from the data. This is data. This side is close to it, but this one is far away. So you place it on the side that is far away from it. Then another thing I want you to know is that when the innermost is sufficiently recurved, contains no ending ridge or rod rising as high as shoulders of the loop, the core is placed on the shoulder. That's what I just said. So now, at times you may see three shoulders. If you have, three. Let me leave that until next week. Now, this at times the type lines is not always continuous. So if it is not continuous, if it is broken like this, the next one that is immediately outside of it will be chosen as its continuation. Look at it. In this one, we have these type lines A and B. But on getting here, this one stop. So the next one to it that we choose as the continuation is this. And this one also will be chosen. This one also, type line B. On getting here, stop. So we choose this one. Choose this one. So this is this area now. This area is inside this type line is our pattern area. Now, you may be asking, what is the relevance of locating a core and locating a data? This is the reason. There is something we call ridge count. And that ridge count is one of those things, important things that we use in differentiating two fingerprints that are of the same group, where you have loop or wall, and you want to differentiate them. One of the most important things we use is the ridge count. So, and the ridge count is gotten by counting the numbers of ridges between the data and the core. The numbers of ridges between the data and the core. So when you know the numbers of ridges between the data and the core, then you know the ridge count. So the ridge count will help you in your fingerprint examination. So ridge count, the position of the core, the position of the data, all this will be known to determine, will be used to determine if there's a match or there's no match. So at times in a place where you have maybe your constituency, there's a kind of election. There's an election, and you are alleging that, or somebody is alleging that there's a election fraud. That is, maybe you are suspecting that some of the opposition party has cheated one way or the other. What you need to do is to call for the ballot paper they use for election, and you don't just, it's not just ordinary by counting, but you examine the fingerprint on them. At times, when you examine them, it may be that you have just only one group, maybe only war, because the person that did it may just be only one person that you print the whole ballot. So what you have there is just only one single pattern. So when you have single pattern, you have war. All the papers, all the ballot papers, you have war. All you need to do is to compare compare some of them, compare them 1 and 2. That is first paper and second paper's print. You look at it, even though they belong to the same family, that is, maybe they are loop, does not actually mean that they must be from the same person. You have to still to go further to know that these are not from the same source, that the details are not the same, because it is possible for in a little society, a little community like that, a little community, you may have maybe majority of them that are from the same group. Maybe all of them are war, all of them are loop. So you cannot use just the group to determine that election malpractice has taken place. You have to go further for the second level of the examination. So the first level will only tell you that there's something, you still need to do something further. But if there is a case of you see, maybe in a document that is brought to you in your office, and the first document, the question document, is having loop, and now the person whom we allege to be the source of the document will look at his fingerprint, maybe the collected one or the one that has been existing. We look at it and you see that the one on the question document is it's war, while the other one is loop. Then you don't need further work. You can see that this one, they don't belong to the same group, so you don't need to go to further detail. It's just to give your opinion that these are not from the same source. This is where we are going to stop this morning, and the next class, which is going to be module 2, we'll be having further or deeper details of how to differentiate these various types, or to identify various types of fingerprint. We still have 2 modules on this same topic, that is identifying various fingerprint patterns. Then we go to another topic. Thank you. Meet you in the next class on next Wednesday.